Hi everyone, welcome to another video on CompTIA Network Plus series. In today's video we will study the topic IP addressing. So let's get started. So the question number 1 in today's video is that which of the following documents describe the concept of private IP addressing, and the options are, these are the documents. RFC stands for request for commands, that describe and detail the description about the private IP addressing scheme. So we have to choose the correct answer, and the options are RFC 4949, RFC 1918, RFC 1208 and RFC 1983, and the correct answer is RFC 1918. This RFC describes the concept of private IP addressing, and the private IP addressing, you people must know that these are the ranges of 10.0.0.0/8 and 172.16.0.0/12 and 192.168.0.0/16. So these three IP address ranges are known as private IP addressing, and they are described in the RFC 1918. So let's get to the next question. Question number 2 is that which of the following solution alleviates the problem of the depleting IP version 4 address space by allowing multiple hosts on the same private lane to share a single public IP address? And the options are DNS, APIPA, NET and DHCP. So the correct answer is NET, or network address translation. So this allows us to use multiple private IP addressing. Let's suppose we have multiple hosts or multiple clients and they want to connect to the internet. Let's suppose we have a router here or a switch and they want to connect to internet. Let's suppose this is the internet. So instead of giving each of these clients a separate public IP address, what we can do is that we can use a single public IP address at the outer interface of the router, and then we can use the netting so that all these clients will use this single public IP address, and inside the LAN they will use the private IP addressing. And these private IP addressing such as 192.168.1.0/24, they can be used by anyone all over the world. So this scheme is shared, and the public IP here multiple clients in the number of hundreds can use these private IP addresses, and on the internet they can share a single public IP address. So in that way we can resolve the issue of depleting IP version 4 addresses, and this scheme is known as network address translation, because we translate the private IP address scheme to the public IP address when the traffic goes outside on the internet. Question number 3 is that which of the solutions listed below hides the internal IP addresses by modifying the IP address information in the IP packet headers while in transit across a traffic routing device? And again the options are QoS, quality of service, DHCP, DNS and NET and DNS, and the correct option is again the NET. So as we saw in the previous questions, that NET translates the private IP address to a public IP address by changing the changing the source IP address inside the IP header from private IP address such as 192.168 to a public IP address that is routable on the internet. So that solution is known as NET, or network address translation. Question number 4 is that which of the following answers refers to a method that binds a combination of private IP address and port number with a corresponding public IP address and port information? And the options are PAT, NAC, DNS and ARP. And the correct answer is port address translation. So again, this is port address is translation is a form of net or network address translation where the private IP address and port number is translated to a public IP address and port information. Question number 5 is that NIP version 4 address consists of how many bits? The options are 32 bits, 48 bits, 64 bits and 1 to 8 bits, and the correct answer is 32 bits. So IP version 4 address consists of 32 bits. 48 bits is a MAC address of IP version 4 IP address, and the 1 to 8 bits, this is the length of IP version 6. Question number 6 is that IP version 4 addresses are expressed with the use of options are octagonal numbers, binary numbers, hexadecimal number or decimal number, and the correct option is decimal number. For example, 192.168.1.10, these numbers are all decimal. Question number 7 is that NIP version 6 address consists of, as we studied in the previous example, the correct answer is 1 to 8 bits, while IP version 4 address consists of 32 bits. Question number 8 is that IP version 6 addresses are expressed with the use of options are octagonal numbers, binary numbers, hexadecimal numbers or decimal numbers, and the correct option is hexadecimal numbers. Question number 9 is that a type of network traffic intended for a particular group of hosts is called, and the options are unicast, anycast, multicast or broadcast, and the correct option is multicast. In multicast, the traffic is intended for multiple hosts or a group of particular hosts. Question number 10 is that a type of network traffic intended for a single host identified by a unique IP address is referred to as, and the options are unicast, anycast, multicast or broadcast, and again the correct option is unicast. Question number 11 is that which of the following answer refers to NIP version 4 loopback address, and the correct options is yes, 127.0.0.1. This is the loopback address in IP version 4. And question number 11 is that which of the following answer refers to IP version 6 loopback addresses, and we have to select two answers, and the correct options are this one 0:0:0 up to :1 and :1. So these are one and the same, but this one is truncated and can be written like this. So these are the two correct answers. Question number 13 is that which of the following allows to determine which network segment an IP address belongs to, and the options are physical address, dynamic host configuration protocol or DHCP, address resolution protocol or ARP, and subnet mask, and the correct option is subnet mask. So subnet mask is used to determine that which network segment an IP address belong to. Question number 14 is that what is the name of a solution that increases the efficiency of IP address space management by allowing network administration to divide networks into subnets of different sizes, and the correct option is VLSM or variable length subnet mask. So in this way we can divide the network. For example, I will write an example here. Here we have a network 192.168, let's suppose 2.0/24. Now I can divide this into multiple network. For example, 192.168.2.0/28. This is one network of a different subnet mask. Again, I can write another network 192.168.2. This goes up to 0 to 15, and the next one we start from 16 onward. Again, I can use the 28, or if I need a bigger network, I can write here 27, and so again so on. I can divide this big network into other smaller networks as I like and as I need. Question number 15 is that which of the following answers refers to the characteristic features of the address range 10.0.0 to 10.255.255.255, or we can write this such as 10.0.0.0/8 IP version 4 address space, and we have to write two correct options, and the options are that this is a class A range. Option 2 is that this is a public IP address range. Option 3 is class B range. Option 3 is non-routable private IP address range. And the last option is that it is a class C range. And the correct options are that this range is a class A range, and this is not routable or private IP addresses range, as we already studied. This is the RFC 1918 IP address space, also known as private IP addresses that cannot be used on the internet. It can be used inside a private lane but not over a public lane such as internet. Question number 16 is that which of the answers listed below refers to the address range of 172.16.0.0 up to 172.31.255.255, or we can write this such as 172.16.0.0/12 IP4 address space, and again we have to select two correct answers, and the options are that this is class A address range. Option 2 is that this is a public IP address range. Option 3 is this is a class B range. Option 3 is this is a non-routable private IP address range, and the last option is this is a class C range. And the correct options are that this is a class B range, and again this is the non-routable or private IP address range, as we already studied. This is RFC 1918 address space known as private IP address space, and it is non-routable. This means that these cannot be routed over internet. They are of course routable over your private lane or over you can also route them over your private WAN, but they cannot be routed over a public WAN such as internet. They cannot be routed over a public WAN or over a public or over the internet. Question number 17 is that what are the characteristic features of the address range 192.168.0.0 up to 192.168.255.255, also denoted as 192.000/16. Here we will write, instead of 0 it is 168. IP version 4 address space, and again we have to select two correct answers, and the options are that this is a class A range. Option 2 is that this is a public IP address range. Option 3 is this is a class B range. Option 4 is that this is a non-routable private IP address range, and the last option is that this is a class C range. And the correct options are again that this is also a non-routable private IP address space, that is RFC 1918, and this is a class C range. Question number 18 is that which of the following answer refers to an IP version 4 address range used for loopback addresses? And we have these 4 options, and let's go directly to the correct options. Yes, 172.0.0.0 up to 172.255.255.245 or 172.0.0.0/8. This is the loopback address range for IP version 4. Question number 19 is that in IP version 4 addressing, the leading octet of an IP address with a value of 1 through 126 denotes that the IP address within that range belongs to the, and the options are class A address space, class B address space, class C address space, class D, or class E address space. And the correct option is class A address space. This means that any IP address that starts from 1, let's suppose 1.1.2.3, or it starts from 10, or it starts from any decimal number up to 1 to 6, then this means that this belongs to class A. The question number 20 is that what is the leading octet value range of an IP version 4 address belonging to a class B network? And the options are 240 to 254, option 2 is 128 to 191, option 3 is 1 to 126, option 3 is 192 up to 223, and option 4 is 224 up to 239. And the correct option is again 128 to 191. So where class A ends, class B starts. So the class B range, first octet ranges from 128 to 191. So any IP address where the first octet is 128 up to 191, then this IP address will belong to class B. Question number 21 is that which of the following answers list the default classful subnet mask for a class B address? So what is the default subnet mask of a class B address? And these are the 4 options, and the correct option is yes, 255.255.0.0 is the default subnet mask of a class B network. You can also write this as /16. Question number 22 is that in IP version 4 addressing, the leading octet of an IP address with a value of 192 through 223 denotes that the IP address within that range belongs to which class? The options are class A, class B, class C, class D, or class E address space. And the correct option is again it is class C, where the class B ends. It ends at 191 and starts from 1 to 6. Then the class C starts, that is 192 up to 223. Any IP address that starts with any of the numbers ranging from 192 to 223, that will belong to class C. For example, if we have an IP address starting from 200.10.2.3, then we can say that this falls in this range, so this will belong to class C. Question number 23 is that which of the answers listed below refers to the default classful subnet mask of a class C network? And the correct option, these are the 4 options, and the correct option is 255.255.255.0. This is the most used network address are the most used subnet mask. In our daily lives, it is also denoted as 24, and the most used network in this range or the class C range is that we all use in our private networks or LANs 192.168 or 1.0. So this is a default subnet mask of a class C network. Question number 24 is that which of the answers listed below refers to a solution that replaces the classful network design? And the options are VLAN, RSTP, SNet, or CIDR. And the correct option is CIDR. CIDR stands for classless interdomain routing. So the C stands for classless means that when you replace the classful design with the classless, you don't use the classes anymore. The classes means class A, class B, class C, but you can use any IP address with the variable subnet mask, then that solution is known as CIDR. Question number 25 is that which of the following answer lists the CIDR notation of the subnet mask 255.255.224, and the correct option is yes /27. So that's all for today. I hope you have enjoyed the video. If you haven't subscribed yet, so please subscribe and stay tuned for the next video. Thank you. Bye bye.